This video is an example of selection of a population in Hardy-Weinberg equilibrium using ants as an example. The ants have 3 different phenotypes: long leg, medium leg, and short leg, and these are the genotypes that accompany each phenotype. Now, to calculate our initial allele frequencies, we have each phenotype and the number of ants that show each phenotype, also the genotype accompanying, and our total numbers of ants, which is 100. To calculate the P allele, we take the number of homozygous dominant ants and add the heterozygous ants multiplied by 0.5 because we only want the dominant allele, and we get 0.4 as our allele frequency when we do this. Now, we can do the same thing for our Q with the recessive allele, and we get 0.6 as our value. Now, to calculate the different genotype frequencies, we take the initial frequency, which for this one was just P squared, this one's 2PQ, and this one is Q squared. So those are our initial frequencies. That's how we calculate it. Then to calculate our frequencies after our selection. So selection, we need our fitness value, which is predetermined. The fitness value just shows how viable the specific genotype is for reproduction. It's a scale between 1 and 0, and 1 meaning it's more fit. Closer to 0 means it's less fit. And so we take our initial frequency and multiply it by the fitness to get our unadjusted fitness level. So we do that, get our unadjusted fitness level for each genotype. Now that we have that, we add these 3 values together to get our average fitness. And average fitness comes, for this specific example, is going to be 0.7. Now, average fitness comes in handy because it's how we actually get to our frequency of each genotype after selection happens. So if this value is, so we multiply our unadjusted survivors we divide our unadjusted survivors by the average fitness, and it will give us the different frequency for each genotype after selection occurs. Now that we have that, we can take the value. So we have the value for the frequency after selection occurs, and this is to calculate our final allele frequency. So in our situation, the value for the homozygous dominant was this, and then we multiply it by 1/2 of the frequency of the heterozygous allele, and that gives us the final allele frequency. And then we do the same thing for the recessive allele and the heterozygous, and this gives us the allele frequency at the end.